So example 4, we're going to prove an inequality. Prove that n is less than 2n for all integers, n is less than or equal to 1. So first we're going to say 1, when n equals 1, the formula is valid. Because we plug in 1, you get 1 is less than 2 to the first power. 1 is definitely less than the 2. So number 2, we're going to assume that k is less than 2 to the k. So substituting k, we want to assume that that is true. We're going to show that k plus 1, so we're substituting k plus 1 for each k we have here, is less than 2 raised to the k plus 1. We're assuming that that is true. So now we're going to use certain things. So use the fact that you have 2 to the n plus 1. That is the same thing as 2 times 2 to the n. So the reason that this is true, so 2n plus 1, if you think about it, we are adding exponents. So here's one way to think about it. When you're adding exponents, if we were to split this up again, what you have is the same base, 2 to the n times 2 to the first, right? If you have the same base, you add the exponents, which is 2n plus 1. So notice that this is the same thing as this here, 2n times 2. It's this written out, just that the 2 to the first power is first. Okay, so that's one way to think about it as well as to why that is true. So next, what we're going to look at is that here, 2 times 2 to the n, that's the same thing as 2 to the n plus 2 to the n. Remember, this is multiplication. We have 2 of the 2 n's. Now to prove it to you, let's do like a number. Let's pick 3. 2 times 3. What's another way to write 2 times 3? Well, 2 times 3 is really 3 plus 3, right? So 2 times 4, that's really 4 plus 4. So we just have 2 of the 2 n's, right? 2 of the 2 n's. So that's the same thing as 2n plus 2n. So all of this is true. And so we just have to remember those rules. And so now, it follows that. So then for n equals k. So we can say 2k plus 2k, that is greater than, so 2k plus 1. Is that true? Well, yes, right? If we plugged in 1 here, that would be 2 plus 2, which is 4. If we plugged in 1 here, we get 2 plus 1, which is 3, right? So that'll always be true. So that is true. I can say that. And then let's say that's also bigger than just, how about a k plus 1? So I chose a k plus 1 because I have k plus 1 here, right? I'm trying to prove that. So k plus 1, that is, if I plugged in 1, 1 plus 1 is 2, right? And then if I plugged in 1 here, that's 2 plus 1, which is 3, and I plugged in 1 here, that would be 4. So this is definitely true, and I could say this. So because of that, it follows that 2k plus 1. So I'm taking that from here. So if I said 2k plus 2k, this here, I'm going to take this and substitute 2n plus 1 instead, or 2k plus 1 instead. So that is greater than this 2k plus 1, which is greater than k plus 1. Now if that's true, then k plus 1 has to be less than this, right? If that all follows. So let's rewrite this. Or k plus 1 is less than this 2k plus 1, which is what we were trying to prove at the very beginning, right here, right? So we did that. So by mathematical induction, the n is less than 2n is valid for all integers, n is greater than or equal to 1. Okay, now we're going to prove that n factorial is greater than or equal to 1 for all integers, n is greater than or equal to 1. So looking at this one, when you plug in n equals 1, the formula is valid because 1 factorial is greater than or equal to 1. So 1 is greater than or equal to 1. We're going to assume that k factorial is greater than or equal to 1. We're going to assume that is true. So show that k plus 1 factorial is greater than or equal to 1. So k plus 1 factorial equals k factorial times k plus 1. So then that is greater than or equal to 1. So that's true, right? So we're assuming that k factorial times k plus 1 is greater than or equal to 1. Now, since k factorial is greater than or equal to 1, so I'm taking it piece by piece. So this piece is greater than or equal to 1, because we have to plug in 1 here, right? So 1 factorial is equal to 1. If I picked 2 factorial, that would be bigger than 1, and so forth. Now, if we did the same thing here, break it apart, k plus 1, is that greater than or equal to 1? If I plug in 1, 1 plus 1 is 2, right, which is greater than 1. So if that's true, thus, what it's saying is that k plus 1 factorial is greater than or equal to 1. So we just added the k plus 1 here, right? So we're saying if this is true, you multiply the k plus 1 to that k factorial, and then you break it apart. So hopefully that helps you out with this type of